So for this question, we're calculating derivatives of integrals. So integrals anti-derive your functions through the fundamental theorem of calculus, and then the derivative is going to somehow undo that process, but sometimes there's going to be some residue, some leftover term that's a consequence of the limits of integration. So you got to remember that from item A here, this integral, if I have to solve it, that is some antiderivative big F of x minus big F of 7, where f prime of x equals to square root of 1 plus x to the 4th plus 6, right? So I got to remember that this is an antiderivative of this function here, okay? So there's this 1, there's this 6, they're split up, but that doesn't matter. That's what I was given. I'm fine with that. If that were a 6 squared or t to the 6th, it would not make a difference. I just plug it back in here. Now when I derive this, I can derive each term separately. The derivative of the first term is just f prime of x, and then the derivative of the second term is 0 because that is a constant. F of 7 is, and then f prime of x is just this. Okay, that's through the fundamental theorem of calculus. So that's what it is. You keep it like that. You may feel tempted to combine these, but it wouldn't help you anyway. I gave you this expression in this format. Keep it in the format I give to you. On this expression here, it's a similar idea. You first use the fundamental theorem of calculus, antiderivative on 5 minus antiderivative of x squared. But then there's one little change in here. Maybe I could do that. And maybe I could box the answer on the first one. When I derive this first expression, I get a 0. There's a minus sign that comes from the fundamental theorem of calculus, and there's the derivative of this guy. Okay, there's f of x squared. That's two functions nested, right? One function inside the other. To figure that one out, I got to use the chain rule. So how do I use the chain rule for that? It's the derivative of the outer function applied to the inner function. So f prime of x squared, just derive that one, times the derivative of the inner function. So the derivative of x squared is 2x. So that's what you have. And remember, f is an antiderivative of the function that's being integrated, of this sine function. So I'm now going to do the sine of x squared to the 6th. So I just get this x squared, and I plug this into the original, the integrand, the function being integrated. And I'll get just a minus 2x sine x to the 12th. And that is the answer for item B. On C, that is a little bit of a trick question. You would feel tempted to do the same, right? But if you note that this guy is a number, and this guy is also a number, this is just a fixed value. There's no x's in here. So this is the derivative of a constant function, which is 0. Okay? Be careful with what happens here. It's as if you had an f of 7 in here. That the derivative of that was a 0, right? And the f of 5 here, the derivative of that was also a 0. So you have numbers in both limits of integration, so both derivatives of both terms will equal to 0.